we're going to talk about solving trig equations. So remember that when in math, when we use the term solve, it just means get whatever the variable is on one side and everything else on the other. And then that'll answer your question, right? So that's what it means to when we say solving it. Now, admittedly, on this particular thing, you're going to find that when you have to do the tangent one, sometimes the answer that you get won't work in delta math because they'll say rationalize the denominator. We can talk about what that looks like. I'll even do an example like that, and you can kind of take those with a grain of salt, knowing that you get as many opportunities to do problems. So you can go on with those. But just so you know, if you want to extend yourself and understand things at a higher level, then the tangent ones are the ones where you're gonna need to challenge yourself on that. So first thing is know that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. If you didn't do the previous work, this work is going to be super hard for you. Know that if we have a 45, 45, 90 triangle, this is the square root of 2 divided by 2. This is the reference angle. This is the square root of 2 divided by 2. And this is 1. If you have a 30, 60, 90 triangle, this is 30 degrees and this is 60 degrees. This is 90 degrees. This side is 1/2. This side is a square root of 3 over 2. And this side is 1. We could turn the 30, 60, 90 triangle up a little bit so that the new reference angle is 60 degrees. And then that's 30 degrees. Then this is a square root of 3 over 2. This is 1/2. And this is 1. A little bit more on this is we're going to be talking about all these problems are going to be involving radians. Remember, 30 degrees is the same thing as pi over 6 radians. 45 degrees is the same thing as pi over 4 radians. 60 degrees is the same thing as pi over 3 radians. 90 degrees is pi over 2 radians. 180 degrees. 180 degrees is equal to pi radians. And then finally 360 degrees is equal to 2 pi. And I actually think radians are a little bit easier to deal with because as soon as you get to understand them, they're actually, in my opinion, they're a little easier to deal with. So let's take this problem right here. Find the exact value of the sine of pi over 4. The pi over 4 is the reference angle. So if you're trying to figure out what the exact value of the sine of pi over 4 is, you have a reference angle of pi over 4. That's 45 degrees. This is pi over 4. So this is the square root of 2 over 2. This is the square root of 2 over 2. And this is 1. If the sine is the opposite side divided by the hypotenuse, then the sine of pi over 4 is the square root of 2 over 2. And it's as easy as that. Those problems should not be hard for you if you've done that previous work. Let me show you one thing that happens when you have to do a tangent one. So let's take this one, the tangent of pi over 3. So this is the one that's going to extend you a little bit. If you have to find the tangent of pi over 3, pi over 3 is a 60-degree reference angle. So it's the triangle that looks like this, where this is pi over 3. This side right here is 1/2. This side right here is a square root of 3 over 2. and this is 1. Now, what they mean by rationalizing the denominator is the following. You know that this is the opposite side, and this is the adjacent side. So when you do this, this problem and you're trying to figure out what the tangent is, we're going to do the opposite side over the adjacent side. And you go, wow, that's a fraction over a fraction. Delta math won't accept that answer. But remember, that's the same thing as the square root of 3 over 2 times 2 over 1. So you can multiply by the reciprocal, and then when you simplify this, you get the square root of 3 over 1. Now that's one type of problem. Let me find one more. Let me think. This is a good one. Okay, so the tangent of pi over 6. So if you have the tangent of pi over 6 is a 30-degree angle. You want to think about it. This is pi over 6. This is 1/2 over here. This is the square root of 3 over 2. And this is 1. Now, if you go through and you solve this one, knowing that, this is the opposite side, that's the right angle. This is the adjacent side. So it's the opposite side divided by the adjacent side. Now here's where it gets a little tricky. So hopefully you follow along and kind of understand what's going on. So this is the same thing as 1/2 times 2 over the square root of 3. Well, those 2's cancel out and you get 1 over the square root of 3. That's not a rational denominator because the square root of 3 is an irrational number. So here are the steps that you would go through. If you have a square root on the denominator, what you're going to multiply by is that square root on the top and the bottom. So I multiplied by 1. What I end up with is the square root of 3 on the top and 3 on the bottom, and that's the answer. So when you get to the tangent ones, you should try them, but don't get too discouraged if you don't get it. But make sure that you give it a try and take a look at that. Now, that was just evaluating basic trig functions. We're going to have to solve basic trig functions. And remember, solving means get x all by itself and everything else on the other side. I do need to let you know that if the sine is the opposite over the hypotenuse, then the cosecant is the hypotenuse over the opposite. If the cosine is the adjacent over the hypotenuse, then the secant is and remember this is an angle, and this would be an angle. There's an angle in here, and there's an angle in here. The secant would be the hypotenuse over the adjacent. And then finally, if you have the tangent of an angle, that's the opposite over the adjacent. So the cotangent is the adjacent over the opposite. So that's an important piece. Now, when you're doing a problem like this, it says solve it for all the values between 0 and 2 pi. This is going to bring some things back together that we talk about that we've talked about in the previous days. We're going to kind of combine some things. So let me do some examples. If you haven't done the previous work, again, this is going to be super challenging. So here's an example. 2 times the cosine of x plus 1 equals 0. So that's 2 times the cosine of x equals negative 1. So that's when the cosine of x equals negative 1/2. Now, think about what that looks like. The cosine is equal to negative 1/2. Remember what we did with that, where we drew those triangles, and we could really draw it in 2 places. We could draw it back here, where this is negative 1/2, this is 1, this is the square root of 3 over 2. So we could use that angle, which is a pi over 3 angle. So if this is pi, which is the same thing as 3 pi over 3, then this is 2 pi over 3. So that's one of our answers. X is equal to 2 pi over 3. If you haven't done the previous work, that probably was pretty confusing for you. But if you have, we're just using the same ideas that we have in the past. Now, the other thing you could get is you could get a situation where you drew the triangle like this in the third quadrant, where this would be negative square root of 3 over 2. This would be 1 still. And we're dealing with this angle down there, which is still the square pi over 3. So this is 4 pi over 3. It's another place that the cosine is equal to negative 1/2. So it actually came up with 2 answers on there. If I show the solution, they'll go through there and give you those 2 answers. So that's the kind of thing that you're going to have to do. Now let me show you this one. This will be another type of problem that you're going to have to do. So maybe we'll finish with this one. And if you need more examples, we'll do another day of this. So we got 2, the sine squared of x minus 1 equals 0. So that's when the sine squared of x, 2 times the sine squared of x is equal to 1. So that's when the sine squared of x is equal to 1 over 2. So that's when the sine of x is equal to plus or minus the square root of 1 over 2. Now, you might go, well, what is that? We haven't done anything like that. That's the same idea as doing plus or minus the square root of 2 over 2 if we do that rationalizing the denominator. Now, with that, what we know is we know that our reference angle is equal to pi over 4. That's our reference angle because it comes from that 45, 45, 90 triangle. This is the square root of 2 over 2. This is the square root of 2 over 2. And this is 1. But what we have is we have the plus and the minus. Notice we have both of them. So we need the reference angles in every quadrant. We need to think about it this way. We need to think about it when we have a 45, 45, 90 there. First quadrant, that's pi over 4. Remembering this is 0. This is pi. For the purposes of this problem, I'm going to think of it as 4 pi over 4. This is also 2 pi. But remember, 2 pi is the same thing as 8 pi over 4. That will help us generate some of these other things because we know that if we draw it in this quadrant over here, this would be 3 pi over 4. We know if we draw it in the third quadrant down here, that's 5 pi over 4. And we know if we draw that 45-degree angle, or that pi over 4 angle in the fourth quadrant, that's 7 pi over 4. So we end up with all of these answers. But again, if you didn't do that previous assignment, this assignment is probably a nightmare for you. So you have to do the practice on these. If you practice them, you go, oh, I see how that can be because you've done so many of these assignments. Okay? And that's the case that I'm going to get at. I'll stop there. And remember, if you have some trouble with these, let me know and let's talk a little bit more